Good afternoon, coders. I hope you guys are doing well. Thank you for joining us. Thank you for joining us. Today we have a session on cybersecurity. We are going to start shortly. We have our amazing facilitator, Joab. Joab has joined us. Today you're going to learn about passwords. You're going to learn about passwords. You're going to have a short demo, or you're going to have a demo on passwords and password strengths and how passwords are cracked. So I want to welcome our amazing facilitator today, Joab. Joab is a cybersecurity expert. Karibu sana, Joab. Take it away.
Can you hear me?
Yes, yes.
Why is my volume? You can hear me, right?
Yes, yes, I can hear you.
Awesome, nice. Thank you, Joanne, and everyone else who is on this Zoom meeting. So I'll just share that screen really quick in a minute. Awesome. So everyone sees my screen, right?
Yes, yes, clear.
Awesome. It to whatever account use, like the 2FA, MFA, and we still need to use password to authenticate, like to show that we are exactly the same person, or whatever person we pretend to be. So passwords are used for authentication, and it's a good practice to have like very strong password. The reason why we need strong passwords is because, like, over the past years, like, people have come up with ways to crack passwords and, like, get access to accounts which they're not supposed to. So most of the applications you use, like, you must have realized that there's a lot of emphasis on having strong passwords. Um, uh, and the question that I will ask, like, is how do you come up with a strong passwords? Like, there are people who use password like, so my name is Joab. I will use password like Joab123. That's very easy to guess. Like, somebody will just try to, like, okay, so Joab, 123 Joab 123, Joab 5. So it's easy to get. So to get and get that. So there are ways you can come up with very strong passwords to help you, make your accounts, like, very strong. And some of this will just, like, go through really quick. Passwords, like, they need to be very long. So most of the times they give you, like, 8 characters. You can go beyond that, make it as long as possible, so long as, like, you can remember it. Another tip on password creation: don't use what that somebody can relate to you and guess. Like, if you have pets, you will use the name of your dog, your cat, the name of your city, like where you come from, maybe the name. Like, some people use their birthday, their names. So try to avoid those, like, a lot, because they're easy to guess. There are tools which can be used to do, like, brute forcing and stuff like that. One good way of coming up with a good password is taking, like, a phrase that you're used to, and then replace the characters, the letters in that phrase with some special characters. For instance, if the phrase is, let's say, Nairobi. So if you have Nairobi as a phrase, so we can replace, like, letters, like, like Nairobi, A with something like @ sign, I with maybe exclamation mark, B, we can replace that with 6 or something like that, just so nobody knows. If you say like Nairobi is a big city, so that's like a phrase, and then you put those special characters in within the letter. So long as like you remember that phrase whenever you want to log into your account. So having said that, passwords are stored like in form of hashes. So a hash is like is a one-way function, like one-way cryptographic function that takes in an input and gives an output of a constant length based on the hashing algorithm that is used. So in modern applications, like passwords are stored in hashes. So if you have an account with Facebook, um, you are not the only person in Facebook. So you will log in with your password. And when you type your password, it is hashed and then stored. So the next time when you log in, they will hash the password you provide and then compare that hash with the hash which is already stored in their database. So if they match, then you log in. If they don't match, then that means like you are somebody else. Um, Hashing is a one-way cryptographic process, as I said, and in a real world situation, a hashing algorithm is supposed to produce an output that is random. Somebody's talking. Okay, so in real world, like a hash is supposed to be like a random um just a minute. Yeah, it's supposed to be a random output. What that really means is like if you know the password, you can generate the hash of that password. But if you have the hash, you should not be able to generate the password or the plain text from that hash. So it's a one way. Once you create the hash, you are not supposed to get the plain text from the hash that you get based on, like, you can use different hash algorithm. Like MD5 is one of the most used hashing algorithm. We have like SHA-1, SHA-2, we have SHA-256, I think, uh, 512, I think. So there's so many hashing algorithms that you can use based on, like, the length of the hash that you want to get. So how do attackers get like password of a person? So the first thing is they have to gain access to where the passwords are stored. This is like, maybe breaching an application like database where the passwords are stored, and they will get these passwords in form of hashes, not like real passwords. So that will be just like the first step, obtaining the password hashes, and then they have to figure out like a way of getting the real passwords from the obtained hashes. So that makes it like, so we are dealing with hash, like how do we decode or decrypt, like, the hash and get the real password from the hashes. So sometimes back, people were able, like, there was a system that was hacked and they obtained, like, like the whole database of stored passwords. And these passwords were like in form of hashes. So the problem was like, now all these hashes are outside of the system's reach. And if they find a way of cracking those hashes, then all the accounts, like, are compromised. So people thought and thought and thought and said, like, we need to come up with a way of making these hashes, like, this password strong. So if you type your password, like, say June123, the system is supposed, like, using salting. Salting means like the system will add like an additional um, characters on that, and then they're hashed together. So the salting portion of that password will be like just a random, which is assigned to that. So if you say like June 1, 2, 3, and then they will add something like mine only. So if that is they hash that and then it produce something differently. So if like an attacker obtains like the hash, it won't be just what you provided. There's like that portion which is salted. So cracking that gives them like, a very hard time. So I want to show you like, how how detecting passwords then. This trend. So I just want to show like, like a really small demo here. We'll use like some three, by the way, we'll use some three passwords there, like for just for demo for the rest of this. So I have these three passwords. So the first one is Manchester 123. The second one is Heartbreaker 07. And then the third one is Estados Unidos 8. It doesn't make any sense. It doesn't mean anything. So it's just trying to make it. So as you can see here, like we see the characters containing the lowercase, uppercase, number, symbol. So the more you meet all these requirements, the stronger the password becomes. So we will start with the first one, which is Manchester. I'll just, so you see, it's very weak. Why? Because, okay, so we have like 13 characters, which is good. We have lowercase, there is no uppercase, and there is no symbol. So it's supposed to meet all these requirements, okay? And then if we try this one, okay, this also like still weak. We have like 14 characters, but we are missing the uppercase or lowercase. So a good password means like you need to use like combination of like, lowercase, uppercase, use like some numerics, some symbols, like, special characters. And then it has to be, of course, like a long password. So how about we try this one here? So you see, it's kind of like, it's strong, like it's good. And they tell you like the time this will take to crack your password will like 257 years, really? Okay. But we're still missing like, like symbols, like we don't have special characters. So the more you include like, all those special characters, you use like, uppercase, lowercase, you use like numerics and stuff like that. That's how like, you enhance the strength of the password. So that's just like, by the way, like whenever you're using passwords, like you might be a system admin somewhere, you might be dealing with very delicate, users' credentials, which need to be saved. Or you just using your own system, like, you connected to a free Wi-Fi somewhere in a coffee shop or something like that. So you need to know like how to get password, like strong password. And of course, like you need to be changing your passwords most of the times, like maybe weekly, 2 weeks, or 1 month if you can. Another thing I'll say, don't use the same password on every account you have. So somebody has like a Gmail, like a Facebook, Twitter, they're using the same password in every account. So imagine like if somebody cracks just that password, they get access to all your accounts. So try to use like different password on different accounts like that you own. Awesome. So the next thing I want to introduce is word list. So whenever we deal with password, like want to crack passwords, we use what we call word list. So word list is like a very lengthy, is a very long list of words, like, commonly used passwords people think of. They're just like, added there. So that's what word list is. So you can create your own word list. So you can say like, okay, so I know this guy is called, let's say Joel, and Joel, so Joel has like a puppy named Ashley, something like that. Joel was born this year. So I will try to use like everything that comes to my mind, I think you could use, and just make that word list. And then I will run that word list again. It's like just brute forcing, trying to see what will match his password. It's 50-50, it could succeed, or it might not succeed depending on the strength of the password that Joel is using. So if Joel is using a very complicated password, definitely like we might not have that on our word list. So most of the password cracking is brute forcing, using rainbow table, you're using, it's more of like, trying to guess the password. And how is this working? So let's say I have a word list with which contains your password like in one line. So how will I be able to get your password? So if I have like the hash for your password, so I will just like, take each word in my word list and encrypt it, like make a hash using algorithm. If I get like access to the hash, I can identify the hash algorithm you're using. It could be like MD5, it could be SHA, it could be anything. There are tools to show that. I will show you that in a few. So once I get that, I will be hashing each and every word on the word list and compare that with the hash that I have, which is your password. So if it matches, and then I will, okay, so this hash matches. So I will go to the word that I used to create that hash. And then voila, that's how we get your password. Um, there's so many word list on like, this security OS, like if you're using Kali Linux, if you're using Parrot OS, which I'm using right now, I'll just show you also that in a few. So the word list, like for DNS, for like, there's so many word lists which have like, have been made with by the open source community. People just like, since these are open source tools, people contribute like, this is the password I think somebody's using. So if you run that, if you go through one of the word lists, you might be surprised that even the password you're using right now is among the list. So I'll try to show you that in a minute. And the next slide is where we go handy, like, we try to do things. So before we got that, the tool that we're going to be using today is Hashcat. I don't know why I chose this. It's just one of my favorite tools, but there's so many tools. I'll show you, like, you can use for password, and I'll show you that right now. So this is, okay, so I'm using Parrot OS on my virtual machine. And if you come to the applications, like the way they do arrangement, I'll just go to the pen testing, and they do. So these are the most useful tools. I'm just gonna go to the password attack. And as you can see, like in the password in the tools section, there's so many tools. So they divide like the local attacks, offline attacks. You can use like, online attacks. You can do password profiling and word list. You can find my hash. So this will help you to find which hash is being used. Or you can use the hash identifier, which I use most of the times. If you come to the local tools, you'll see like all these tools you can use locally. Offline tools, these tools you use to crack like passwords offline. So you'll have like, like a database which you downloaded somewhere with hashes, and then you work offline. You don't need to be connected on the internet. And we have tools you can use to crack like online passwords online. So it's a lot. The choice will depend on like, what you feel comfy with, what you have like some experience with, and just how you feel like, what that can do. So there's so many tools. One of the tools where is my tool? Where's my tool? Offline should be offline, and here's my tool. So we'll be using this today. You could use John the Ripper. You could use Johnny, which are really good passwords. You could use like, this for rainbow attack and so many. So we'll go that. So here we go. So on my list, I did choose to go. We will be playing around with, sorry, undo that. So we want to play around with these tools. I mean, these 3 passwords. The aim of this goal is to teach, to show like, how we can do that. So the first thing we want to do, we want to use like 2 algorithms. So we'll use this hashing algorithm, MD5 and SHA-1. So we'll have to create the hash of these 3 using the MD5, and create that file, and then also create that using SHA-1. So how do we do that? Okay, so here we go. So our first password is Manchester123. Okay. If you get a question along the presentation, don't hesitate to ask. So, no? Somebody is asking? Hello?
Yes, Simba, Boaz is the one who's trying to ask a question. Maybe you can try be audible, Simba.
So I'm saying this. At the moment you have started on hashtag God knows. Can you check
Sorry, there's a lot of echo on the background, so we don't get like the words clearly.
anytime?
You can go ahead. Okay, so I'll take the first question from Khadija, who asked like, remembering those different passwords are great effort to some people. Should we write them down somewhere, or is it risky? You mean like the word list? Or if you mean the word list, then there is no, it's open source, like it's open to the community, so you can use them, you can download. I will try direct to like find like those online, so you can use them, like they're for community use. That's why they're open source. They are open to community. You can use them, like, and to use them and share them with people, so long as like you are not breaking into some stuff without consent. That makes it a problem. And then Simba. Oh, not the word list as a way of strengthening one's password. Oh, should you write them? Oh, sorry. So I'll go back to your question, Hadija. So the question was really quick. So remembering those different passwords that get effort to some people, should we write them down somewhere, or is it risky? Oh, definitely not. Don't write them down. So a written password, like if you write a password down, that is like as useless as like not having password, because like if somebody get access to that, then like whether you have a very strong or like very weak password is still of no use, because they can use it. They can take just like a picture or like copy it. I know of like a situation like, this company used like, their users they were forced to, they're like a password policy. Each and every second week, they're supposed to change password. And sometimes like those passwords which are generated by the system admin. So some people used to take like, they write that password and then they stick it on their screen, which makes no use. If somebody comes, we have something called, shoulder surfing. If somebody comes like from behind, or maybe pretending to asking questions, something, they see the password, and then your life with the password is done. Like that's the easiest way it's stolen. So don't try to use something you can remember without writing it down. I think that answers your question, Khadija. And then we have Boaz. How do you keep your passwords safe? Well, that's a very good question. How do you keep your password safe? If you're using if you are not really good with remembering passwords, their password managing system, like tools you can use, they will keep all your passwords together for your account. But there's a risky side of that. So you have all your passwords together. So if somebody breaches or get access to that system, then you're also done. Most of the browsers, I know, like Chrome, Mozilla, they have, like, this password system. I mean, so whenever you log in using that browser, they ask you if you want the browser to remember your password, and then they keep those passwords locally on your computer. So that's a way of remembering. But again, if that is a shared computer, is not your personal computer, don't do that, because anybody could go to the browser and go to the settings and find your passwords, in plain text. So unless it's your computer that you're the only person with physical access to it, you can use that. If that computer is shared with somebody, or, like, sometimes you leave it where somebody can reach it, then I don't recommend that. Just try to use something that you can remember without writing it down. Joanne is asking a question from my DM. Can we use any terminal to do what?
I think she was meaning the terminal that you're using there, if she can use any terminal to do whatever you're doing.
Oh yeah, you can use any terminal. yeah, you can use any terminal. So yeah, you can use. I mean, terminal, it doesn't make any difference. It's just I know. It's like the way you code. You could choose to use Visual Studio. You could use Notepad++. You could use whatever, like, you feel good with. You could use, if you're using Windows, you could use CMD. You could use PowerShell. You could use anything. You could even install, like, something else you feel comfy, so long as, like, it gets the job done. So terminal, that is nothing on your way. Should it be a big deal? So we good, like, so far so good, right? Perfect. So I have wait, so I did say, so we're gonna try to change this. We're gonna find a hash with this, with MD5, all of this, and we create something. So I will just I will create something like nano, let's say demo 1.txt. Okay, and in that, we're gonna be saving the hashes we have. So let's go back here. And the first password is, we'll do something like echo en, and then is Manchester 123. Manchester 123, right? And then I will grab that and do something like so. So we're gonna be using MD5 Sam. So this one will create, like, a hash for this word here, Manchester. So using the algorithm, I mean, this function, MD5 function, and let's see. So this is the hash for this. And one thing that I want you guys to understand about hashing. So if we use MD5, the length will be the same, whether this word is just one word, or if it's like the whole page, or like 500 pages. If you hash it with this function, you'll get the same length, but of different, like, with different hashes, but the same length. So that's why we use, like, if you want to get like a very longer hash, you could use something like SHA. So you will see like if you use SHA and compare, the SHA one will be longer than the MD5 function. So we have the first, we know this is for, I'll copy this. We know this is for Manchester 123, and I will put it there. And then the next password is heartbreaker. And I will do the same, but I will have to. So we have heartbreaker. This should give us like another hash, the same length, but different. So you see, it's the same length from where I started from here, but it's a different thing. So we have this hash. We will also add it there. And then we go to the last. The last one, which is okay. So we will copy that and come here, and we will just change. If you have any question, just drop it then. Okay, so if we have that, then we have another hash, same length, but different, like, hash. This is unique. This is a unique just for that. So I will copy this. Really? Okay, I'll just copy that. And go here, and then we have our last. So we have those three. Because we know what that is, we just want to show that we can crack this one and get our passwords back. And again, this is not salted. This is just like, the password, which is hashed. There is no any salt we adding on that. So salting is an additional layer of security that is implemented to make it very hard for people to crack. So we have that demo one. I'll just save that. And yeah, so if we cut demo one, so there we have our first text. So if we see that, so we have our demo one here. And yeah, so we have RockU. RockU is the word list. So if I show you, like, maybe it's a very long list though. So if, oh, my font is small. Let's see, how do we, is that works? That should be good, right? I hope so. Okay, I think that's good. So we have password for this. So we'll just create another file and make the same passwords using SHA-1. So I will go back to that. And I wanted to show you about, like, so RockU is a very long list of is a long word list. So I'll just open another terminal here, and just, if I cut RockU, it's gonna take a while because it's very lengthy. So it will take some time because it's very long. So you see, like, all these are just like password guesses. Like, people just put there most of the passwords in alphabet from A to Z with all new. So you see, like, all this is a list of like so many passwords that people think people use. It's a very lengthy. So what we will do, we will just like run what the tool will do. Hashcat will run the hashes, so it will be taking each and every word from this list, hash it, compare it with the hash that we have. If it doesn't match, it goes the next and next until it finds what matches that. If it is not in that list, then we won't get the password. This is a very resource intensive process. And that's something that I need to bring up. Like Hashcat needs a lot of graphics. Most of the times, like it recommends to using something like an Intel processor, which allows it like to do the processing. So yeah. So back here, so we have seen like the content of Roku. We created our first demo one text with MD5, and then we're gonna create another one. We just do something like nano, and this will be like demo2.txt. And what do we do here? So we will go. This one is also small. I'll bring it bigger and clear this. And now we want to do the same with SHA-1. So I'll copy that. And what I'll do like echo, and then the word, which is Manchester one. And then we will grep it. And instead of MD5 SAM, we will use SHA-1 SAM. So this uses like a different hashing function. And if you do this, you'll find that, you see, this hash is now longer compared to the previous ones. The previous ones were shorter. So I'll copy that and take it to our, yeah, so we are here, and then we'll go there and copy the next password. Copy that, and then I'll do the same thing instead of, I'll just, sorry. So heartbreaker, and that should give us another one, which is that, and we will go to there and paste it there. And then we are left with the last password, which is that. I will do exactly the same thing and generate that. So that's the last hash we're using. So
hello, Job.
yeah.
I think there is a question from Jacob. Have a look at it, maybe.
On the chat?
Yes, yes.
Jacob Morecha. Okay. So Kali TTY1, how do you solve that? I have a dark screen after logging into Linux. Okay. So TT1, that means your login is that user one. Can you try something like start X, something like that? Should give you like a quick graphics. I think so. On the command, just like start X, and let us know like how it goes. Or we can help you like with that after like we're done with this if it doesn't work. Okay, just remind us, Jacob. Okay. So here we are. So we're gonna save this. We will save this. And yes. So let's see. So we have two demo docs. So the first one, if we cut demo one, those are the hashes we have. If we see demo two, oh, sorry. I'll just clear this one so that we can compare. Demo 1 should give us that, and we do demo 2. So you see, these are shorter because this is like, this is MD5 function, hashing function, and this is SHA-1. So this is kind of like, lengthier as compared to this. So we will try to we know like these are the same password, like the same password, just like different functions. But we're gonna try to use hashcat with the MD5 and then hashcat with the SHA-1 and see if we can recover the passwords. And then that's how we will be breaking that. So I don't know if Jacob, you got like assisted with the question you had. All right. So let's go. So I will introduce you guys to hashcat. But before we go to hashcat, I want just to use another tool. So you remember like in the password place, we are like, so you see like the find my hash and hash identifier. So let's assume we don't know, like we just have the hash. We don't know whether like which function is used, whether it's MD5 or it's SHA-1. So first of all, we need to know, okay, so what exactly are we dealing with, like which hash function? Maybe it's salted. So we need to know that before we start like, cracking it. So how do we do that? So I will do like, it's called hash identifier, if I'm not wrong. And this will give us, so this hash identifier will help you to identify which hash. So let's take, for instance, this one. If we copy this and we paste it at the bottom here, so that's the hash. This tool will give us like the most possible hashes being used. So let's see. So you see it ran and then it gives you like, this is the hash, and then the possible hash, MD5, which is exactly the same hash we used to, you remember like we use MD5 to convert that. So this is the possible hashes is MD5, and then these are the least possible hashes that it gives you. So we'll go like with the first, what it gives you here. Let's do that again with a different. So we pick that one from the top. Let's use any of these and copy that. And we post that. We know this is SHA-1. Let's see what it tells us. If we got that down, and you see possible hashes, SHA-1 or MSQL5, which is still SHA-1. So we will go this one. So this is like very accurate tool. It gives us the exact function we use to hash the passwords we use. So before you start like cracking, you need to know exactly, okay, so I have like these hashes, like this length. So what kind of hash am I using? So at this stage, we know exactly that this is a SHA-1 and the previous one was a MD5. So I'll just exit that, and then clear my screen. So yeah, so let's go to hashcat, and if we do just help, it will give you like, it will give you like information about this tool. So let's just go through this one really quick and see like what we're dealing with. As I said, this is a hash password cracking tool. The usage, they tell you like you're gonna use the hashtag and then the option you want. There are different options as we'll see from here. And then the hash, this is the file which contains the hashes. And then this is the dictionary. The dictionary, this means like, in this case, the word list, the rock you will be using. So if run properly, just as simple as that, you should be able to get that. But before we go that, let's see like some options. So, we're dealing with different hashing functions, and each functions are like its own option to use with the tool. So this means like hash type. So M is hash type, and then A is like the attack mode. It could be like reference below, there are different reference. So this gives you like the version, help, anything you need, a timer. So if we come all the way down the way they give the numbers somewhere. Okay, so this is the hash mode and the number they give you. So this is like the category. So if we're using like MD4, so we will use like the mod should be this 900. If you're using MD5, which we will be using, so the mod should be 0. If you're using SHA-1, the mod should be 100, and it goes all the way down. So these are for like, this up to this point of just like raw hash, like the ones we have. But if we were to use like a MD5 hashing function, which is salted means like that password, and then there's something added on top before it is hashed. And then instead of using 0 for MD5, this is salted or iterated. So we'll have like 10 and so forth. And so this is very like, self-explanatory. If you are interested in this tool and you feel like you can't get like, help from just using like the help option after the tool, you can go to the website. Should be like hashcat. Should be like hashcat.net. They should give you like they have like resources here. They have like the wikis, forum, tools, events. So if you got the wikis, hashcat like this will tell you what it is all the way, other attacks, attack modes, dictionary attack, combinator, and then the wiki pages and resources. So they have the how-tos, like how to use it, videos, papers, articles. And this one, they even like, you remember like last time we talked about conferences? Here they have like the cheat sheet. They have like people doing a presentation in conferences, like there's somebody who did something at DEF CON. Yeah, you see? So in 2010, somebody used this tool at DEF CON. So if you go to this write up, you will see like how they did the demo, and you can just learn how to use this tool. So it's open source. Yeah, they have wikis, forums, and all that. So if you got this website, you like get all the details you need to use the tool. I think that gives you like, way to go. So I'll just close this and close this, and let's get back to the terminal. Okay. So we know we're using the attack mode should be, the first one is MD5 for the demo one. And then the second one should be SHA-1. So just very fast. Did they say something like attack mode? This is attack mode, hash mode, and then did they give option attack mode? Which attack mode? See references below. Okay, so let's go. I'll just clean that really quick, and we'll do hash cat, and we're using the mod. Our mod here is we will use MD5 in this case, which is 0, and then attack, which is also 0, and then we need to provide the file that contains the hashes we have to crack. So in this case, we're gonna be using the first one, which is demo1.txt. And then after that, we need to provide the dictionary. In this case, is our word list, which is ROCU. So we will do ROCU text. So what this will do, this calls the hashcat toolkit, and then it tells it like, hey, we are dealing with this 0, we are dealing with MD5 hashing function here, and we need to crack it here. And then it tells it like all the hashes are like stored in this file here, and we want to run the hashes stored here against the possible word list, like words in this file. So this will run if we click. Wow, that's fast. So you see that very fast. And then here info, all hashes found in port file use show to display. So we will just do the same and show that. You see? So we run this. So the first one, the password is Manchester 123. The second one, this is the hash. And if we go back the same, if we can match that, it's the same thing. So the first one is Manchester 123, which is this. The second one is Heartbreaker 07, which is here. And then the third is this one, which is here. So this means, you see these words here, they are contained in our word list. So it's as easy as that. So long as like you have the hashes, and you know, like this is hash which somebody's asking questions really quick. Check it out. Okay, I'll try to help you after that, Jacob. Just remind me when we're done with this presentation and questions, okay? So we have cracked the MD5 hashed function with the password, and we got the passwords here. So imagine if I have like, have like Twitter account, my LinkedIn, my Gmail, everything that I'm using account, if I was using the same password. So if somebody has it, like they can access every account I have. So that's why I said, if you can, it's a good practice to look like use at least one password for each account that you own, so that like, if by mistake it get compromised, not everything is lost. Like, you can just, if it's your Gmail, you can just like talk with the Gmail, do and reset, and but if it is like every account, then that puts you like, you call it like a red zone, hostile zone.
Excuse me.
Yep.
Now, my question is this. Now, you remember these hashes we have, we generated them after, we had passwords.
Yes.
That's when we generate the hashes. But in a scenario whereby you don't know the password, how can we crack the password? We don't know the password, we don't have the hashes. How can we retrieve the hashes that may facilitate us to crack the password?
Okay, good question. So because this is a demo, this is for educational purpose, I did show like the whole process, like just to know like these are the passwords we're using, and then we hash the passwords. So when it's hacking, the process starts like where we have the hashes, not the password. I just wanted to show you like how the hashes are created, like are generated. But like when the attacker will only be able to access the hash, not the password. So the goal will be to crack the hashes to obtain the password. So you see, like that's like a very well defined process. So get the first goal will be to hack the system or wherever, like with a database, gain access to the hashes. And then the next stage is to find the best way to obtain the password in plain text from the hashes. So I did show how to generate the hashes from the password, because I want you to understand the whole process. Like,
okay.
I don't want to get the question like how do we get the hashes? You get that? And on obtaining the hashes, that's where the hacking, like the bad guys come in. Their goal is to compromise. So they will hack like a system, like whether you have like a dynamic website where like people log in and they have like credential, that means you'll be having a database somewhere in that where you host your system. So if they can be able to access that, they will definitely be able to access the database which contains the passwords. And those passwords will be in like, encrypted like in hashes, not like real passwords you type on your web application. So the goal will be like, once they obtain that hash, how do they get the password so that they can, I don't know if you get the point.
I'm getting the point. Now, when I heard that today we are going to learn this subject, to some extent, I was very happy, because what came in my mind was cracking the password, the example of the phone. Like I forgot my password of the phone, and I was like, what do I do? Now, my question is this: at the end of this lesson, or rather at the end of this subject, will I be in the position to crack password for phones, like my phone, for instance?
You want to crack your password for your phone?
Yes, I'm just for instance. Yeah.
So that's a very good question. So my goal is to entice you, to ignite that curiosity in you. Okay. I can't show you everything, how to crack your password, your phone. It involves a lot, the hacking process as stages, you need to do like recon, gather information, know about like system. And then your phone is just like your phone. Everything that is managed, the passwords and everything is being operated by third party. So if maybe you forgot your Gmail password, that one you need to find a way to hack Facebook. I mean, not Facebook, Gmail, Google. So
Sure.
it's a long process. I just need you to understand. So if you're interested, and then you'll find a way I want to go deep into this. How do I get resources to help me understand and do that? That's the goal of this whole presentation. Is not to come and show you like, hey, this is your
Sure.
phone. You gotta crack it. Like,
Sure,
you get the point?
Sure.
Yeah. So my goal is to give you that curiosity to want to learn more, to know more, and then do search for more research. That's how we learn. If you are like given everything, like, hey, I just need it. Hacking is not like you have like a red button somewhere, you're just gonna press and you hear like that magic voice like we are in. It doesn't happen like that. It takes a lot of work, a lot of time, a lot of research to do, because on the other side, there are people also being paid every day just to secure that thing you're trying to get into. And you don't need to hack something. Don't put yourself like into a problem, get these skills and find a way to do the good thing and make money out of it. Like you don't wanna hack Facebook, like my Facebook, and then you go to jail for 5 years.
Sure.
Don't do that.
Yeah, sure.
Okay, so we good, right? The goal
Yeah,
is to help you get the skills, try to learn, and then make a career out of it. Get money, get paid for hacking if you want. Don't hack to go to jail. That's the whole thing. Okay.
Thank you.
Awesome. So, Joanne, we have any question before we proceed to the next hash function?
Yes, I think Hadija is asking a question. I also have a question after everyone has asked.
Okay.
Hadija? Yes, in the chat.
Oh, the salt. Who salts the password? So no matter how strong your password, is it being hacked? Is a higher possibility? Okay, so salting, like the salting is inbuilt, like the people who design the systems, they build that one as like additional security layer. So you don't need to know what happens on the back end. So you will just provide your password. So even if Adija and Joanne and me, we share the same password, the hash will be different because you will get a different password, I mean, a different salt. Joanne will get a different salt and I'll get a different salt. And then my password plus that salt, if they're hashed together, they give like a different hash. So the system will remember your hash. So whenever you log into Facebook, you provide your password like Facebook123, and then because Facebook knows like your account is Hadija, and then it goes to the stored salt for Hadija, and then it adds that salt on top of your password, and then it hashes it, and then it compares it to the hash which is stored. If they match, and then your login is successful. If not, then the system will think that you are somebody else who is not Adija. So salting, there's like nobody doing salting, is inbuilt, like it's a automated process, like part of the login process or storage of passwords. I don't know if that answers your question, Adija. So no matter how strong your password is, being hacked is high. Not really. So the stronger the password, the more time is needed to crack a password. So let's say I have a password like, I want to create like a very strong password from just down here, if you guys can see. So let's say let's say what? Can somebody just throw like a phrase, something? Okay, I'll just find something. I use like Nairobi. So this is a phrase, is a, let's say like is a nice city, okay? So this is something I can remember because I've been to Nairobi. I love Nairobi, it's a nice city. So how do I make a password out of this? So the first one, I will just make it like one thing. And then after I have this, so the length is obviously like really good, you see. Now I want to make it a password that I can remember. So I will start like Nairobi, and then R maybe 0. And then for B, I can use like 6. And then I, and then instead of S, I could use 5. And then @ sign. And then N, I could use like a capital letter. And then exclamation sign. And then that C. And then E, use something like 3. And then this C, maybe capital. And then this I, and then instead of T, I use like 7. And then use Y. The same thing, I remember like Nairobi is a nice city, but like this one, I don't know who will guess this and get it. Unless you have like even the system will take like forever to guess this, because this is not something like a word somebody will remember. It's a phrase from a sentence. And then out of that, I have made it like my own way. So if we use this, like we have the uppercase, we have lowercase, we have like numbers, we have special characters and stuff like that. So this is the best way how to create like, stronger passwords. Come up with a phrase that you remember. And then from that phrase, jungle it, like make it something that makes sense. Like I can still read this, like Nairobi is a nice city, you see? So if this password will take like forever to crack using like Rainbow or whatever, because I don't really think if there's something like this on a word list. You just come up with a phrase, something that means something, or maybe like my dog is turning 2 years today. That's a phrase. Put it together and then jungle it. Like put those words, mix it. Nobody will remember like you came up with something like my dog is turning 2 years today. So I don't know if that helps. Adija? Yeah. The next question was? No question yet, right?
There is a question that I think from Simon. He's asking, and is the online account password protection different from network password protection like Wi-Fi?
Wait, what?
Simon, the online account password protection, I think for passwords that are stored in servers. I'm not sure.
Is that like on the chat?
Yes.
Let me see.
Yes.
Let me check. Where's my Zoom chat? Okay. From Simon Under. Okay. And is the online account password protection different from network password protection like Wi-Fi? So for the Wi-Fi password, depending on like, whether the Wi-Fi, the way the Wi-Fi is installed, I think all the password like for Wi-Fi are stored locally somewhere like on the access point, or if you're using like this network like this radius system, which is centralized. So that is stored like in the controller. There's like a network controller that is like, manage the network locally. For the online passwords, these are stored like online based on the application you're using. So for instance, if you're using Facebook, Facebook stores your password somewhere like on their server somewhere like, I don't know, in California, wherever they have their data center. If you're using like a website, which is, if I created like a website and I needed to get people to log in, And then my hosting, like I will be paying for hosting, and then in my account, I will have like a database of people who connect to that. So it depends with exactly like, you know, the kind of application, which online application you're using. Yeah. So network storage is different from like online, I think. But the end of the similarity is like they're being stored somewhere, either on a device, a controller, on a server somewhere. They're being stored somewhere. So that's why like whenever you connect to a network, you log in, you type the password, and then that password, they try to match it to what is stored on the access point or the wireless controller. If they match, then you're good to go. If they don't match, then you need to get password. I think that answers like, you know, Simon's question. All right, so the next, we've seen how to do, this is MD5. So we're gonna try to do like with the SHA-1. SHA-1 is kind of like a stronger function as compared to MD5, but MD5 is most, I don't know why it's mostly preferred. Most people use MD5 for hashing. I think somebody also asked a question like, what's the difference between hashing and encryption, right? The difference between hashing and encryption is like, for encryption, like you can, it's a two-way. So if I have encryption, I will have like, you know, two keys, private key and public key. I will use the public key to encrypt a plain text and jangle it up. And then on the other side, the person who is supposed to get the message will use a private key to decrypt that message. That means we have a plain text, which is encrypted, and then the encrypted text, which is decrypted using like a decryption algorithm to obtain the plain text. So you see, that's a two-way. You have a plain text, you encrypt it using encryption algorithm, you get the encrypted text, and then on the other end, you need to have the private key plus the decryption algorithm, and then you get the private, the plain text. So in this case, with the encryption, you can obtain the plain text. With hashing is a one-way. You have a plain text, you hash it, you can't get it back. You just get the hash. That answers the person who asked like the difference between hashing and encryption. I hope so. Next, we're gonna do the same thing we did, but in this case, we will use the same, but we'll use the SHA. So we'll crack this using the SHA. As you guys remember, we did create like, you know, just clear dates. We have the demo2 file, which is made of hashes for SHA-1. The same passwords we created, but like now, I want to like know from a hacker's perspective, this is what they have. They don't know what they're dealing. They just have these hashes, and the goal is to obtain the plain text from this. So if I was like a hacker, like when I talk about hacker, like, you know, like a black hat, like somebody with ill intent, I will take that. And the first thing I want to know, like, okay, so which kind of hashing function I'm dealing with. And as I did show, you just use like, it's hash identifier. And this, we just put that hash, and kaboom, we know we are dealing with SHA-1. So this is the hash. And since all the, we know this is SHA-1, but since in that list, the demo2 text, all the hashes have the same length. That means all the hashes have the same hash function, like the same hash function was used to generate that. So we know what we're using, okay? So we will just proceed the next level, clear that screen, and then do hash card. We will mod. So in this case, since we're dealing with the SHA-1, I'll just show you that very fast before I do. So you see, like for So at the beginning, like, for MD5, we use the mod for that to use 0. But like right now, we're using a different hash function. So instead of 0, we're gonna use like, the mod is 100 to tell the system that, this is Shawan function. So M will use 100, and then is attack will be 0. And then we need to provide the file that contains the hashes. In this case, should be demo2. And then we have our what? We have our word list. In this case, is the rock U. So this should be done. So if we do the same thing again and do something like show, boom, you see, it cracks that and matches it. So the first one is the same Manchester one. The second one is Heartbreaker. And then the third one. So we have been able to crack that, okay? The goal of this presentation is not to understand like which tool to use, is to understand the concept, the process, get to know the process, understand the concept. And then from that, you are in a very good position to decide, okay, so which kind of tools am I supposed to use to reach my goal, to achieve whatever like I'm trying to achieve. So that is for password cracking. So there's so many tools you can use. There's so many techniques, rainbow cracking, there are brute forcing. We use like the word list and stuff, which is similar to dictionary attack. So if we go back to that, so we have done the demo for that. So I just want to also show you like, password cracking countermeasures. So how can we do, what can we do like to encounter that? If you are like a security person, like, you are tasked with making sure that like, all the system people, your clients, people you're serving are protected. The last thing you don't have is like, here, like we have 1 million people's like, details exposed like on an online forum with passwords, accounts, names, addresses. You don't want to have that as a security. It's like the worst nightmare of a lifetime. So I did say avoid short and easily predictable passwords. Try to have like, they provide, I think they say they use at least eight characters. But right now I see like there's some systems like, they require you to have at least 10 characters in a password. So the longer the password, the harder it becomes to crack it. Also avoid passwords with predictable patterns like your name and then 1, 2, 3, or your name and then your date of birth, or the name of your boyfriend, your girlfriend, or the place where you are, or the name of your pets. Try to avoid those. Those are like easily, if somebody knows you, they will try to predict, just guess, and be able to get the password. Password stored in the database should be encrypted so that if by a mistake, if the bad guys get their hands on that, they still have good, really hard time to obtain the plain text. So password should be encrypted with very strong encryption algorithm. And again, as I said, like, change your passwords occasionally. There's this bad joke they say, password is like an underwear. Wear it once, change it often, and then don't let anybody see it. So keep changing your password like the one you're using. Nobody should know your password, even you are, I don't know, is your password. And then, as I say, don't use the same password for all accounts. Like, try to use, like, if you have a Facebook account, have a password for Facebook, for Twitter, for Gmail, for your LinkedIn, for your, whatever the account you're using, try to have a separate password for that. It's a good practice because if something goes wrong with one account, if one account is breached and your password is exposed, then you don't worry about other accounts. If you use the same password, then that's a nightmare. So yeah, that marks the end of this presentation. And now I welcome, like, any question, anything that relate to this or outside the scope of this presentation. I'll be happy to answer that if I can. To you, Joanne.
Oh, thank you. Thank you so much, Joab. I think there are some questions on the chat. There's still some questions on the chat.
Let me just go there really quick.
Okay.
Okay, so Simon, how different is hashing from English? I did do that. Mariam can't see. Oh, you can't see my screen? Is anybody?
Oh, sorry. I think they can see now. It happened a few moments ago for some people. Maybe it was a network issue. Yeah.
Okay. And then Simon, and is the online account password protection different from the name? We did answer that already. Okay. Simon, there's another question about that one. They were supposed to relate it. Huh? What? I mean, Simon, you need to clarify that. Oh, this is okay. So Jacob, Joab. Oh, this is Joab. It's Joab. Joab. I think I solved the TTY1. How do I make the display full screen? Just in a few. Jacob, I will help you with that. Yeah. Jacob, how do I make Parrot display full screen and not the maximize window? Jacob, click on that screen and then press Control and Alt and then enter. That should help you go full screen. Let me know. Margaret, from what you have shared, a software engineer should sort and hash their user passwords before storing them. What are some of the factors to consider when selecting the hashing algorithm? What should you use for? Okay. Two, first of all, what are some of the factors to consider when selecting the hashing algorithm that you should use for your passwords? Okay, so one thing you consider, like the first thing we know, like, each hashing function, like, takes like different length. So your storage, you want to consider that, like how big is your storage? You need to do a research. Which one is strong? Like, I think MD5 is good, but SHA-1 is also like the SHA-1, SHA-2, SHA-3, they are strong. MD5 compared to MD4, MD5 is good. So you want to get like, how strong do I need this hashing algorithm, hashing functions to be? That will help with determining like what function to use. Your second question is like, based on your experience, which hashing algorithms would you recommend we become familiar with? I will say you be familiar with MD5 first. Is like, is one, like, get to understand MD5. Once you understand how MD5 hashing function works, you will be able to understand other functions as well. I hope that answers Margaret. And then we have Miriam. Yes, Parrot is a Linux distribution built on Debian, on top of Debian. It's more the same as Kali Linux. They have like, open source. It's open source. They have like a community, and they have like, tools which are really well put. I prefer Parrot, like, based on my experience, because there are some tools which you don't find in Kali Linux. For instance, I'll show you here. And there's some tools like Kali Linux deprecated, like right now, they don't support, you need to install them manually, which is, so for instance, like you see this list, you'll find all this in Kali Linux, but Kali Linux doesn't give you this automotive. This is like for car hacking. So this makes it like, if you're interested in like, in cars and stuff like that, right now, this is not available in Kali Linux at the moment. Another reason why I like this is because it's easy to navigate, move around. And yeah, one of my favorite tools, the volatility, they removed it from Kali, like it's not supported right now. So, I mean, I have both Kali, I have like different tools, but this one just like whenever I open like my system, I just find myself going to Parrot. So yeah, another question that you ask, yeah, I did answer. That is a Linux is based on Debian. So if you're used to using Ubuntu, you know how to handle like Debian packages and stuff. You'll be good to work with Parrot and Kali Linux. Ruth Kaveke. Ruth is saying, wait, I lost Ruth. Or password manager recommendations. Oh, let's see. Password manager recommendation. Some password manager are free, like open source, and some are paid. I need to do a research on that. I don't have like a preference because like right now I'm not using any password manager. I remember every password I have. So Ruth, for that I will have to do like like a research. I can't recommend you like right now. And then Simon, it's fine. I got it. I asked the question on hashing and encryption too. Okay. And then we have Margaret. Okay, thank you. And Ruth, yeah, MD5 was cracked by a researcher somewhere. And that's why, like, whenever you see, like, so we had like MD4, and then MD4, when they realized it was weak, kind of compromised, and they came up with MD5. And right now we are moving to SHA, and all this, like, the more you go. But I think the reason why I recommend somebody to get like, really basic understanding of MD5, because it gives you like, that understanding like how the hashing works, because these are some of the hashing algorithms, I mean, functions that were built like before these other like new ones like SHA-1, SHA-2, 56, SHA-5, 12. So for me, I'll recommend somebody to get like understanding of this, and then if you do understand that, and then you will know why you need MD5 or why you need SHA-2, something like that. So yeah, Ruth, that you're probably right. So I think like we're done with the questions on the chat. So unless there is any question like vocal question or like some questions from the other platforms you guys are live streaming this, I will be happy to take them. Back to you, Joanne.
Oh, thank you so much, Job. I was just asking for a comment about something. I hope I'm not putting you on the spotlight with this question, but there was a research that was being done this year by, some researchers. They were showing that a couple of apps and even sites that use third-party login, they use that OAuth for third-party logins. They don't implement security, they don't encrypt, or they don't do anything. They just depend on the authorization of that application. So also, what is your comment in terms of people using apps that have third-party logins?
Okay, so this is my view. First of all, let me try to explain like what is you said right? So the way it works, it tries to minimize the time and remember the password. So for instance, if you have like a Gmail account, you logged in, and then you have Facebook, or like you download another app, like let's say what app? Anything that requires you to log in. So instead of like every time logging in with that app, you just like give it like you authorize it to use your Google, like, your details, your login from Google, so that they will obtain like your credential from Google. Like, once you allow it, it will get your credential from Google and then logs you in. The good side is like it makes life easy. You don't need to log in every time, type password and username. The bad side is your credential, like, third party, which you don't have control over. If something happens with your Gmail, then Gmail is responsible. But once you allow Gmail to give your data to third party, and then they are not responsible, you have to deal with these people, and these people you didn't give them, they took it from Google. So, and then you don't know how, like, what else they do with that. So there are so many questions. Like, I don't prefer that to the earth, because it puts like a lot of risk. Like, there's so many questions, like, why is on my mind, like, whenever something like an app asks me to implement like the earth. So for me, like, for security purpose, I prefer typing my password by myself. I prefer not clicking on links. I prefer like typing a link word by word. I mean, letter by letter by myself. If you send me a link, I will look at it. Like, if I don't feel like clicking it, I will type that by myself. So yeah, for security reason, I don't recommend somebody to use the auth system. There are so many security questions um, in place, like what happens with your data, who else has like access to that, what do they do with it, like, why can't they just take it from you? There's so many questions. So for me, I don't recommend using those. I don't know if that answers you. I mean, it wasn't like a spotlight. It's something I've been also doing a research on behind the scene. So you didn't actually put me on the spot, Joanne.
Thank you. Thank you so much. On the live sessions, there aren't any questions so far. There are some who are appreciating that they're following the session. Victoria, she's appreciating. Thank you so much.
Thank you, Victoria. Wherever from where you're watching from. So there being no further question, I think this marks the end of today's session. And thank you everyone who took their time to attend this session. I hope you learned one or two things. Yeah. So thank you everyone. This marks the end of the presentation for today.
Wow. Thank you so much, Joab. That was remarkable and it was very engaging. There was the last question actually from Jamila in the chat.
Okay.
Yeah, she was asking some sites like Codula. Codula was actually one of the tools that we used to learn to code mobile application development. It's very similar to MIT App Inventor. And then she's asking, it has Google account sign in. It also has passwords, username and password. And then she's asking about the security issues in that. I don't know.
So the Codula platform, they only give you the option to use the auth, like the Google account?
No. They give you an option to sign in with GitHub, with Google, and then, okay, with username and password. Yeah.
I mean, I'll go with the username and password. As I said, it depends how you take your security. For me, I won't prefer using the author, where I give them, or I will give them I'll sign up with an account which I don't feel for my Gmail, I won't use my Gmail because I have my stuff in Gmail in case something goes wrong. I will use if I have to use, I will use something like maybe Facebook, they will post things they will access still your data also. I won't do it for me. That's my take. So I will just go for typing my own username and my password, which I remember. Somebody's asking Jacob. Oh, My GitHub. Oh, by the way, my GitHub, I have like, have like so many forked resources there. So if you're interested wait, is that my GitHub? Let me just see. My username. Is it that? Really quick. GitHub. You all see my screen, right?
No, we can't see your
Oh,
screen.
you can't?
No, yeah.
Ah, sorry. I'll just share that really quick. Somebody asked my GitHub is jcourses00. Yeah, that's my GitHub username. That's like what from Jacob. Rose okay said no, I don't really know that what it means.
Oh, she was answering the question of whether she can see your screen.
Oh, sorry. I think I stopped sharing. So yeah. So if there's any question, I'll take. If we are good, I'll pass it back to you, Joanne.
Oh, fantastic. Thank you so much, Joab. As for the GitHub account, I can see most of you are interested. We shall share with the video that we are going to share in your WhatsApp groups as well, so that you can have a look at the forked resources that Joab is talking about. So thank you so much, Joab. That was amazing. On my end, I love learning a lot. The resources that you provided since we began, and as we are progressing along, we've learned a couple of amazing stuff. I really appreciate that so much, Joab.
Thank you very much. I really appreciate that as well.
Awesome. So thank you so much. So I will call it an end to this session. Have an awesome evening, everyone.
You too.